Welcome everyone to this very, very special edition of ALN Thursday at 3. We're calling this the ALN AiBrainStorm, PortsSTORM, and I'll get into more about that later. But I wanted to welcome you and let you know the people who have been participating in this. But as we always do to get started, we want to thank our Platinum organizational member, ONUMA Inc. And we want to thank all of our patron members, Jacobs, ABS Quality Evaluations, Definitive Logic, CGI, and thank all of our organizational members. We're very lucky to have such great support from a wide range of people willing to do a lot of different work. And this is really special, but we've got the UN coming up next week and the week after. So please keep in touch with us and what we're doing here. It's very exciting. And it's quite appropriate that during our 10th anniversary of the Asset Leadership Network, that we're leading the port industry into a vision of its future. The tools that are coming out of the human brains, the evolution of artificial intelligence, the acceleration of digital twins are very confusing for people. However, an asset management governance approach allows very complex issues to be governed, understood, administered, and mission outcomes can be dramatically improved with this governance. And we're so fortunate that John Arnott from Trent Port Services is a member, and he is also a leader in the port industry, and he has been guiding us to use these tools. He and his colleague, Jay, at IGO Solutions have some wonderful technologies that match up perfectly with some of our other members. So this is a combined presentation of how ports can address the very complex set of assets. They've got ships, they've got containers, they've got cranes, they've got trucks, they've got trains, they've got warehouses, they've got office buildings with operation centers. And all of these things are operating in different silos, just like in every other industry. And it's our pleasure to be able to show how an asset management governance approach allows the information for all of these different asset classes to be organized and have predictable visual outcomes. So enough about me talking about how all of this comes together. Why don't we switch over to John Arnott, president of Trent Port Services, and he'll be able to start the presentation. And then Kimon will come on with the handoff of information about the ports and how port decisions. John, are you able to turn on your camera and
yes,
start sharing your screen?
Yes, I can, yeah. So yeah.
Welcome, John, from Jakarta. I don't know if you're actually in Jakarta, Indonesia, but thank you for waking up in the middle of the night to present with us.
No, pleasure to be here, Mike. I am in Jakarta at the moment. So yeah, great pleasure to be here, indeed.
So it was really great. You participated in the Ukraine BIM storm last year, so you got a taste and understanding of how digital twins are being used in asset management. Then you saw earlier this year how the artificial intelligence fits in, and you and your colleague at IGO Solutions you're already incorporating artificial intelligence in it. So why don't you go ahead and share your screen and tell us about port asset management. And for everyone attending, this is not only for ports. We're using ports and the information about ports, but these same processes and same tools can be applied to any industry.
Okay, so we just run with my slides, yeah?
Yeah,
Mike?
sure.
Okay.
If you're able to, there you go.
Okay.
And while you're getting that set, I should let everyone know to chat or send questions.
All right. Okay, so I'll get started then, Mike, yeah?
Sure.
Yeah. All right. So this is the, yeah, and Mike's done the introduction on the AA and digital twins governed by asset management. So we said there we'd start with a benefits statement. So I'll take you through some quick benefits here that these are real situations in terms of what we have achieved over time ourselves.
And
so,
I left something out of your introduction, John. I need to say it's really important that John and his company, along with iGo Solutions, worked on the Rotterdam port and used many of these tools and processes to set that port up in its new approach. And it became the first port to be ISO 55001 certified.
Yeah, no, that's right, Mike, and thanks for that. And that's kind of part of what you see here. So we did a very large global rollout of asset management for ports. So we kind of portized it in line with ISO 55000, and our goal was compliance at the time. And for those choosing to go on to certification, that was their choice. And Rotterdam went on and became the first port to be ISO 55000 certified. So that was part of this team as well. So some of these figures in front of you here, they're high level. So just going to show you snapshots on a couple of the high level savings, some operational savings, etc. So this is a high level snapshot of CapEx and OpEx savings. These are all figures that were signed off by the port CEOs at an early stage of the asset management rollout. So other than what you see on the screen in terms of figures, things that we recorded other than the financial gains were things like improved line of sight, clarity around the mission of asset management, processes and procedures that became a lot clearer, motivation within the people and the port itself, communications, as you would expect, happier teams, believe it or not, and as a measurement, certainly a more consistent focus, less silos, as you would expect with good asset management approaches, and then a creation of that was quite effective in terms of implementation of shared KPIs. So on this one here, this is an operational side of it. So in terms of what we delivered and recorded on the operational side, things like improved yard crane work distribution by 15%, increasing productivity by 2 moves an hour, which is quite significant overall in terms of revenue and obviously productivity. A 35 to 50% reduction recorded in what we call rehandles. That's the unnecessary handling of a container in order to get to the container you actually want. 25% improvements in external truck turnaround times. Significant if you want to keep the hauliers happy. 15% reduction in travel distances of internal port trucks. And so all of this was showing a direct result in reduction of fuel usage and maintenance requirements. So here is a technology. So this is an AI technology, which we'll discuss a little bit later. So the example is relating to a 60-strong fleet of rubber-tired horizontal equipment, like a truck-type vehicle that carries containers between the ship-to-shore crane and the container yard cranes. So there's a conservative value. As automated terminals, for example, the value can be much higher due to the cost of interruption and stoppage. So we use using advanced AI technology here, delivered and witnessed our ability, or the ability of the solution, to predict an asset breakdown or a failure 2 to 4 hours before it actually happens. So accuracy prediction obviously improves through machine learning over time. So this is currently about 80+% accuracy in that failure prediction. And again, all of this adds up to reductions in operational downtime, increased productivity, and all good stuff that the ports like to do. So here is just a snapshot graph. So everything that we do in our preparation work, delivery, and our measurement going on from that is just captured ultimately in this highest level of however you track your return on assets or return on capital employed and what have you. So just wanted to show.
Well, John, so those benefits are staggering, and you had that done for 5 different ports that have terminal equivalent units, which is basically 40-foot long cargo containers, and there was 600,000 to 1.5 million of these containers. So when you're reducing throughputs by even 3% or increasing efficiencies by 25%, those numbers are mind-boggling.
Well, that's right, Mike. Yeah. So these are all 600,000 to 1.5 million container-sized ports. And so these were all container ports. We didn't cover general cargo at the time. So that was, and these were all on different continents. So we had an Africa, an Asia, a European, a Latin American. So we kind of cross cultures. So that was also one of the aims, that we did cross cultures, so we could understand how one program was going to fit, work, and benefit a port on each of the continents, which is what I showed you. So the efficiency and the optimization, productivity improvements, revenue improvements are certainly one thing, but the list I gave before, the knock-on benefits of breaking down silos, creating better focus, happier teams, was very much a relevant measurement that we did see coming out.
Excellent. Thank you.
Yeah, so we'll get into the 2 scenarios. So the 2 scenarios we were going to run through in our Port X was what we referred to as current state, and then later on as a future state. So the current state is just really to set the scene and outline a typical problem that we see when we move into the port, and that's ourselves and people like Jay from iGo Solutions here. So we'll set that out. We'll run through some of the solutions and technologies that we use with Kimon, and then we'll just attach that to a future state and give a brief on how we go and solve those problems. So what we see here is just a Port X. So it's what we show you, everything that we'll show you in the next half an hour or so is applicable in any part of the world, and that's pretty much part of our asset management approach in being able to deliver anywhere in the world. So the illustrations that we're using here are just publicly available information. The data is industry kind of benchmark standards, but it's hypothetical for purposes of this this webinar. So here, and I'll just give that
John,
video a bit of a tip.
Should I play the video?
Yeah, just
If you stop sharing the screen, John, Kimon will share it.
That's okay. If it works,
is this working?
Yeah,
it
it's
might be
going
okay.
fine. It's
Might
going
be
fine.
Okay.
okay.
So it's just it's empty, but it's a simulation. So just imagine this as being full of containers. So I'll just throw some industry sort of standards that we use. So berth occupancy. So this port, as a hypothetical sort of real life scenario, the berth occupancy would, for example, be 70% capacity. And so in our world, when you get above 70%, you start seeing ships stuck at sea. That makes them unhappy when they're waiting outside. So that's where, when a berth capacity gets to its max, then you start affecting the customer. The container yard, about 70, 80%, but at 70%, you're really looking to develop the new port. At 80%, you're struggling with performance and productivity issues. Truck turnaround times, I mentioned that earlier in some of the benefits. So causing problems with the hauliers when you're at capacity, obviously things slow down a little bit. The rehandles I talked about, you start digging into boxes a bit more. So the whole thing starts to creak and slow down. and you know, and that sort of spells out the basic problem in the yard and on the berth. And then of course that impacts the cranes as well and how they perform. So Portex, typically, if you take a fairly typical scenario, a lot of data sits in ports. A lot of it will be in silos, and some of it will be good, some of it will be used, but getting the complete picture can be a challenge. You get assets in distress, you need to dig around a bit to understand what that then distress is. Then you talk about the customers and try to understand their complaints and the performance issues. So in terms of Portex, obviously need an answer. And so what we'll go through now as we start getting towards an answer for the future state is we'll look at some of the tools here. So one of the tools that you'll see is our need to analyze, and that will include the processing side of the port. So here is now the beginning of some of the tools and the solutions that we use. So in front of you here is a business process mapping solution. So this is all online and fully integrated. And when I say integrated, connected into here will be some of the terminal systems as well that will be driving this. So we have a globally proven business process mapping solution that is used in ports. In its ideal holistic state, it's applied across the company and covering all departments. So everything we do, as you can see from the slide here, connects back up to the port's business strategy and the strategic objectives and the goals. That in turn is informing the SAMP, which you see in the screen here. That's the Strategic Asset Management Plan. That's a living and breathing document from the asset management world that is driving the port business, and everything from there flows back down and across the business. So that's basically representing a comprehensive interconnected suite of business processes and procedures throughout the port. So there's a lot to this. It's just a snapshot of the very highest level.
But I would like to say how this maps directly to ISO 55001. Your strategic asset management plan shall reflect your organizational objectives. And there is risk management requirements in there. So this is why you were able to get Rotterdam ISO 55001 certified.
Yeah, no, that's right, Mike. So, and when we talk about across the holistic view of BPM here in the port, we're talking about operations, engineering, IT, the senior management with the strategy. We're talking about the commercial teams who are winning customers, you know, and loading up the port potentially. So, you know, so we took this up in ISO 55 compliance. The risk management was ISO 31000. That was the framework we used around that. So, and this was then port-wide. So correct, yeah, that's exactly why they ended up being compliant, and then two or 3 years later went on to become certified. So and Kimon, I guess this is something similar that you would use outside of the ports as well, correct?
Yeah, this was really interesting for me because you're showing a business process model and you're heading towards how does this model actually start interacting with your digital twins and AI, which is key. You don't want to just create a model that's kind of a standalone, but all that knowledge and logic is incredibly valuable, especially if you drive it into simulations and modeling in real time and all that, real-time connections to the actual physical models.
Yeah. And it's one of our really important baseload works to understand that process before you can start putting the tools on top of that and get into the simulation world.
Yeah, exactly. In the digital twin world, there's a very important concept that you have to start from the use case. You can't just start from the tools or the solution. You have a very specific use case, which I think is what this business process model drives. We need to achieve this. How do we make it happen?
Yeah.
Mm-hmm.
And then I just showed this here before moving into the digital twin slide, because of course behind every solution, whether it's a business process mapping solution, a simulation, a digital twin, or your building information models, Kimon, there's always a structure in place to allow for the data ingestion, analysis, and obviously so much more, and that's all taking it on to its final visualization destination, which is what ultimately the end user gets to see. So again, I think, Kimon, a structure like this is something you're very familiar with in what you do on the BIM side. Yeah,
absolutely. This is basically the framework that allows the connections to happen, right? All these different layers and technologies and information and knowledge and data and AI and all that. Yeah, so this was very exciting when you first showed it to me because it's very similar to some of the concepts coming from the building.
This is your Lego slide, Kimon.
Yeah, it's a version of the Lego. Yeah.
Various external sources, and then all of the layers and how they plug in. Yeah, and that was one of the wonderful things about connecting with Jay and John is they knew your language and you were able to start running very fast. I got to stop interrupting, but this is really exciting.
No, but it is really good. It's been fascinating working with Kimon, but you realize the similarities that we both need and we both hold in terms of processes and logic and structure when we're building quite advanced models. So it's really, really interesting. Yeah. So the visualizing, the digital twin and the implementation. So quite a busy slide, but the slide is here showcasing and defining a strategy on how the real world can be modeled into a realistic digital twin at minimum cost. And as we all know, the digital twins can be expensive. So with ingested data in place, really it's all about these visualizations and simulations and analysis of the various events around the port, the operational moves and all of the different scenarios that will go on and be played out within a port, whether you're analyzing an existing one or looking to develop your expanded area, your future state. Engaging with port owners is obviously, it goes without saying, when you're engaging owners and representatives, is a key element in what we do. So when you watch Jay at work doing this, some of the outcomes will be quite new to the terminal, or it will see something that the terminal is not seeing or not understanding. So there's a lot of questioning, and that's where the engagement really sort of nails down those scenarios, and it helps us then decide on the most suitable and the most optimum outcomes that can be accomplished at that port time and time again, and all informed using these data-driven models. So, and the beauty of this really is that when you update your model, so say you add a new berth, or you want to expand an office building, an operations center, it's a really quick and definitive way to accomplish that task once you've got this this baseline set, and it does allow the ports to move forward at speed and with great accuracy. And so again, I guess, Kimon, the question, this is also familiar to you, and it will be a very much a similar approach that you use for the buildings and infrastructure, correct?
Absolutely. Yeah. I'm going to reference this slide later because it's a great slide.
Yeah. Okay. And yeah, so just getting towards the end, a couple more on the tools and the solutions that we use. So just showing this slide really to show the port and everything that Mike covered in terms of warehousing, et cetera, et cetera. So this is the holistic view of an AI-driven simulation. It's, you know, our so-called hyperspeed platform for the ingesting and translating and the cleansing of data. So from the multiple sources. So we take in there's many sources in terms of building these models. There's no restriction on the amount and type of data, and external systems such as weather stations, marine traffic, pilots, and a lot more. Internal systems will be things like what we call TOS data, which is the terminal operating system, key system in any port. We have the EAMS, which is the enterprise asset maintenance management system. So that's like your Maximo, whatever you're using. Any asset related data, cargo types, cargo properties, vessel arrivals, rate of current operation, customer habits, important on the land and the seaside, truck appointments, terminal congestion, communications, any manual or Excel documents, and again, much more. So this is our the holistic view of where we grab and take all of our information. So so again, something sort of relevant to you is sits with you, Kimon?
Yes, of course. Yes. And later on, we'll be talking about how all this relates to the physical, the design and construction of facilities, for example, assets, buildings, but still related to all this. And that's the key difference I think we're messaging here, is that these systems of systems, once they start connecting to each other, that increases the value of the overall system and the infrastructure and the asset management. So this is really exciting to see.
Yeah, this is the Asset Leadership Network holy grail image. All of these silos are melting down and can be worked with a holistic approach. And that's only possible when following a structure like ISO 55000.
Yeah, no, that's absolutely right, Mike, and just such a great point, because you know, that holistic word is so key. Because of the systems, I think today, and the way that they act independently, but the way they act together when they're working and collaborating, the amount of data that you can process in the way that you process it is just incredible, and that, I think, is why we get some great outcomes from here. So just on a couple of solutions that I'm going to deal with here. So on the right-hand side is an AI-driven solution. Again, it's an AI-driven technology. It's been around for actually a few years. So with this one here, we have the ability, using this advanced AI technology, to predict an unexpected equipment or an asset failure before it happens. So a manual to an automated terminal will be quite different. So for the ability for if you're running an automated terminal, which the whole world is slowly moving that way when you're seeing new developments, taking corrective action before you have a failure within an automated environment is absolutely mission critical. So we were able to predict failures within 2 to 4 hours before they actually happen. And so that's just a snapshot of a dashboard there where people could see, you know, that they might have 2 hours and 38 minutes left, and they could understand what was going wrong, what the system was saying, and then predicting, you know, having a decision to make before it physically failed within the operational environment. So that's pretty exciting technology in terms of managing an operational asset. On the left-hand side, we have DigiLife. So I describe that like an advanced electronic brain that sat inside a Crane PLC. So the cranes today that you see on the image there. So most of those cranes are well, I would say all, but I'm going to say most will be designed in accordance with the international standard we refer to as FEM. So FEM is it has a lot of design rules around cranes, and so they cover the structure and the different systems. So systems such as hoist or gantry or the boom and the trolley motions are all covered under these design rules. So this brain sits inside the crane. It has the FEM design rules for that crane embedded into it. And then for every single move it makes, it's calculating how this crane is getting used, how it's aging, and how it's deteriorating against its design life. So at any point in time, one will be able to see the remaining life, not only of the structure, but of the systems within it as well, all against the FEM standard. And just on the last one, really, on our solution, before we talk just the future state of the port, it's just procurement. So and just to really sort of state here that aligning, we've done a lot of work in terms of aligning procurement activities, whether that's the procurement of a crane or a piece of equipment, or down to a spare part. So we do all of this in line with how the asset is being utilized. So we get it specified correctly for what it needs to do today with future proofing, and take on obviously the criteria for that. So that's something that we very much govern under the asset management focus. Everything is driving up to the asset management. So that's about it, really. So in terms of the tools and solutions, have you anything more to add on your side there, Kimon? Because our final sort of area here is to look and discuss that future state.
Yeah, I think one point to make before you get into the future state is even the current state is amazing what you're already doing. And I know that the technologies are evolving. And another point I think that's important to make is that you've been doing parts of this for quite a few years. It's not like AI just came up this year, right? You've been using machine learning and AI and other tools to optimize all this complexity.
Yeah, I mean, that's absolutely right, Kimon. And I think you see a lot of really good stuff going on in the ports, and it comes back to that holistic word again. You know, so occasionally you will have somebody take a much bigger picture view of it, and I think that's exactly what we're trying to get across today is that if you have a problem or you're looking to expand and develop the business, that you do take that holistic view. It's not actually so difficult nowadays with the tools and the solutions and the know-how, but you do, and it's inevitably we get dragged in to find piecemeal solutions, which are good in their own right. But you fall short if you looked at a port that really took on that holistic approach.
Yeah, you don't have to throw everything out. You can build on top of that from a digital twin perspective. It's kind of systems connecting to each other. It's not a monolithic one big solution that's doing everything, which is what's exciting about this webinar is we're kind of showing the connectivity and the opportunity to be able to create those connections.
Yeah. And I think we'll cover that in terms of the business processes, because obviously we don't come in with a whole brand new suite. You do take on the rest of it. So in Port PortX, in terms of what we're now calling the future state. So we've seen the AI tools and the technology that we're using, and so now technically, hypothetically, we get to work. So I'll start this again. Just bear with me.
So the future is that Port X existing capabilities are maximized, and now there needs to be an expansion. And we decided on this scenario because John said most of the ports around the world are in that situation. So this is something that could be readily adopted by ports.
Yeah. And so maybe a point on that, Mike. When you're talking, we went through current state and we showed it at capacity. Some ports will wait to capacity, but then it's a panic to develop the expansion. But with everything we're doing now with this technology and the way that we can get set up, when you're nearing capacity is the time to think about what the new development should look like, because it might operationally be quite different to the existing one, and then the two have to marry together. So let me just let this run in the background. This is our future state. So we have a new updated business strategy, goals and objectives that have now come out from the current state, and we start to simulate here what is the best operational mode. So there's a few different modes that you can run, mainly at the yard side, with these great cranes that you see here. So there's a few. So this simulation will then work through and help understand what that best operational mode is. At the same time, we start to identify green solutions, and we connect that to the port group, so port group owners, and even country strategies where you see a lot of drive coming from different green solutions, because that will affect your equipment choice and even potentially how you're going to operate those in this simulation. So we use that the data again from the existing to the new terminal to correctly size the cranes as well. So I'd mentioned the FEM, and there's a broad range of that, and not uncommon actually that my team and myself have seen is you'll end up with a crane that's been over specified, and it's not uncommon. And so the way you utilize it is not how you specified it. And when people think it's retired, it's actually got quite a lot of design life left in it. And you've paid for that, and people tend to get rid of it before its time is up. So at the same time, we in the simulation, we can look at optimum quantities, ratios of trucks, these yard cranes, the grey ones, the blue ones, which are the ship-to-shore cranes. And then we go into what Kimon will pick up on later. We take that whole approach into buildings. So where we correctly size and position buildings and offices, power generation, water, sewage, etc. And all the time, just allowing for the growth, the potential embedded into that design, knowing that when we've looked at the market and we've got the business strategy, that we can grow, that we have the ability built into the system to grow. We do the same for the maintenance workshop, inventory, and so on and so forth. So just as a finish to this one, once we've done this and we have our business process map with place, we can take all of that data from the BPM, and we can accurately define an appropriate organization with detailed roles, responsibilities. We can build from the BPM into the training solution, which would drive your whole onboarding or refresher training strategy, and all of that would be mapped into the existing current state terminal, even though the two terminals could be operationally quite different. They still have to work together. There will be a crossover of skills and people, customers probably, and so on. So, and then probably one of the last things that we've stumbled across in our asset management world is when you really get close to that finish line, is understanding the new organization operating culture. And that can have a bigger impact than many probably think about or maybe understand. Just that a new terminal brings a whole new organization ideas and a new culture, and you need to make sure that's correct and you're recruiting accordingly and it's mapped into the existing port. So that is really a simulation snapshot and around the future state. So I don't know, Mike, any questions, or Kimon?
Well, there is one here from Mark Knight, an ALN Senior Fellow, but it's going to get answered when Kimon moves the port over, talking about lack of space for expansion. Without, you can stop sharing your screen, John, and Kimon can start setting up. Without stealing Kimon's thunder, we'll show later on how this is moved to a landfill area in Tokyo, where we know that they're planning a port. So yes, Mark is the answer to your question.
Okay.
Great. Thanks, John. That was great, and a lot of inspirational use cases there in real world and in the future state as well too. But the most exciting thing for us when we started talking, this has not been going on that long. Obviously, we worked together on the microgrid for Ukraine BIM-storm, but this particular work has been going on between us for probably less than a month, two weeks.
Less than 2 months. Less than two months.
Yeah,
we started we had our first meeting on this 7 weeks ago, and then we didn't meet again for another 3 weeks. So it is very fast, very fast.
And that's what's exciting about this. It shows the opportunity of when you have like-minded systems that can connect to each other, or even like-minded organizations sharing information, what's possible. So all the massive amount of data that you showed that spans entire planning to operations, to simulations, to AI and digital twins, I'm going to actually rewind back to some of the work we did in 2003 with the US Coast Guard, specifically about how their Coast Guard cutters drive the need for space and facilities, and how do we manage that supply and demand? How do we simulate that using building information modeling, GIS? It was actually Google Earth before it was called Google Earth at the time. Coast Guard is one of the early users of that because they have worldwide facilities, they have complex needs, and we actually built a system for them that actually received several awards called the Command Center, the Sector Command Center Planning System. It's kind of a mouthful, but essentially it's how do you rapidly configure 60 command centers that you typically take almost a year to get design and planning done, to do it in minutes or hours or days instead of months and years, and to do it across entire inventory. And it was data first. What's the use case? The use case is we needed to plan and design quickly. But the most interesting thing about this was waiting for a solution like AI and digital twins. There was a lot of the elements of that, but obviously 20 years ago, the technology was much different. And now with what you've been guiding us towards with the need for command centers and operations centers and ports, it was interesting to me to see, okay, the reason that person sits in that seat and there's a monitor there is driven directly to a business process need of needing to support the cranes, the different types of cranes that you have, and the moving containers, and the fact that port facilities and containers are constantly moving, even though they're very much like a building, and that you have to track that movement has always been very intriguing to me. So that connection to the business process modeling that you showed that goes down into very detailed kind of rules, and then very high level rules that are driven all the way from people and cranes and movement. How can we use that to apply it to building information modeling and geographic information systems and digital twins? So we're essentially taking what you showed earlier and showing that future state, and this is the vision of that. I want to acknowledge that Cyril Verlet from CDV Collectus is on as well too. Our group through ALN has been not prototyping, we're actually using this in actual projects to go the entire life cycle using building information modeling, all the way from data drivers and to how you hand it over to the design and construction team. So we're kind of in the building space, but also very much touching on the entire life cycle and portfolio, and then how do you apply it to ports? So the future port, if we take port X that you described, and we imagine these needs as kind of assets sitting in the landscape. Okay, we have the need for a terminal building, we need warehouses, we need housing for the people that are working there. Should the housing be at the port, or should it be a few miles away in the city? Those kind of big decisions impact everything basically. And how do you simulate that and still tie it to the port? We also focused in on the command center, the operations center, and using AI. This is actually an AI generated image driven from a description output that we had from our data that said, here's a number of seats and workstations and monitors and views of the port that we want to have. So we can quickly kind of simulate that environment and then iterate the design back and forth. With everybody in your team and in IGO as well too, we started capturing those kit of parts, the drivers of why do we need, what type of data, how many cranes drive the need for space, what happens if you move it to another facility, because around the world the demand changes. So we were spending a lot of time, not a lot of time actually, it was a very short time, capturing those drivers to put them into the system, into our system and into other applications, and then create that view on the bottom there that you see. Well, here are all the elements that would be needed for a port container terminal building. And then taking those drivers and asking, pushing them to building information modeling. Okay, now we actually need to see a BIM for design and construction. But before we get into design and construction, we need to simulate and do costs and does it fit, and all those kind of questions that come up in the design process. So we have our own tools for doing that online, and I'll show it briefly later. It's a program to BIM. We essentially feed all this data into the database, the ONUMA system, and then we can start querying it either manually or with AI. That's the interesting thing about AI. Before, we had to kind of pick things out and feed databases in it, but we're experimenting for quite a while now, for several months, 6 months or so, using these new tools, even ChatGPT, to drive and create building information models from prompts entered into ChatGPT or entered into different inputs. And those inputs are driven from the rules that we talked about earlier. So if you adjust the rules, then the idea is that the output should change. If it's a dynamic system, you don't want to have just a static three-dimensional model. Just like containers are moving, requirements are changing. So this is an example. Once we had loaded it all in, and this is still very early testing for the port model itself, the engine for AI driving that, we started pushing data into AI and then asking it questions to output the results to give us a list of spaces that generated the first version of a BIM that could be used for design and construction, and then rapidly configuring it in our application and in Revit and other BIM applications, but essentially pulling that data into BIM and starting to do quick stacking to see, does this fit? Do you want an operations center, the RCOS, Command Center Operations Center on the 5th floor? Does it make sense so you can see the port facility? What does it look like when you start pulling it into other applications? Like this is SketchUp. And like John mentioned earlier, it's really not a software or application driven first. It's really a use case. And why do we need to get this kind of information out to be able to get a vision of what the port of the future would look like? Connected to this, we said, okay, what happens if we take the port of the future and move it to Tokyo? The reason we're moving it to Tokyo is we had an exercise with CDV Collectus involved as well a few months ago with the AIA in Japan to plan and design very rapidly waterfront development for housing and mixed use. And actually, there was actually a commercial port there for a passenger terminal there. So that this is kind of a model of that. And these are some of the results from that model. In other words, this process applies for anything really. It's really information driven from building business process modeling into BIM, into GIS, into digital twins, to be able to then drill all the way down to, well, there's my asset of the piece of equipment that's failing. How do we maintain and manage that? All of this is just IDs and tags and data that is linked together. And now I'd like to kind of demonstrate a little bit live of what we did with the ports. Any comments or questions as I switch over?
I just want to copyright IM. It's no longer BIM. It's IM. It's information modeling, because a cargo container is not a building. And
That's right.
all of the information about that, it's about modeling everything.
That's right. It's all just information driving into different, sometimes physical models, sometimes business processes, sometimes charts and graphs, and sometimes different kind of visualizations. It's all just information driving through it. So
I think
this
is fascinating. I think, Kimon, in terms of the AI, the ChatGPT stuff, and how you are able to put a question in and bring that information out, and we did it on the port side so far. So for me, it's just a game changer, I think, this one.
And what Kimon's doing is loading your rules, John, into
Exactly.
AI and is asking AI to use your rules. So it's not just the general, going into any AI. He's building his own kind of semi-custom approach.
Yeah, we're still testing a lot of that. There's a lot more that's possible, but we're just scratching the surface. Once you have data parked somewhere that you can get to, then you can start querying and using it and connecting it to other systems. So this is our online tool that we use for building airports, where it's kind of an Amazon shopping cart that you go and you request things and it starts building a BIM from that, or an IM, whatever we're going to call it, or a digital twin. But we actually then configured it for the port rules that I mentioned earlier. So these port rules are captured in just starting with spreadsheets and starting with writing narratives inside. So it's a mixture of data and narrative about each one of these spaces that was then driven into our system, just like this. And we hit submit, and it goes and grabs the relevant data, pulls it all together, pulls what's objects and information are about BIM, and starts building a model from that. The first version of a model that can then be used to do the blocking and stacking that I mentioned earlier, which would end up kind of looking like this. So once you get it in our model, then you can do edits and say, well, I really don't want this space here. I can start to move things around essentially. And then while you're moving and designing, it changes the output. So if you want to get a sense of how much things cost, or does it make sense to put a stair here? Or does it make sense to put, so those, it can get very, very detailed down to why do we have this asset here? The reason we have this asset here in this operation center is because of the rules that you gave us, John, that said you need this desk and these kind of monitors here, and this is how much space it takes. Those are very important. There's a reason for everything, in other words, right?
And Cyril, if you could come on. Cyril Verlet is president of CDV Systems, and he has been working with Kimon. And can you talk about the importance of, not just why that equipment is there, but then what happens with that information?
Well, internal in those components has a data structure that allows information to be placed by various folks working on those models, whether it's the architects, the engineers, the contractors, the subcontractors. And what you end up creating are assets that are data rich for downstream use. And this workflow also allows the owner, as this data is being entered, to check to make sure that have these various folks been entering the data properly, or have they entered it at all? And again, the intention here is to create data-rich models for harvesting into this program like BIMgenie, with as a CMMS program, or space management, asset management, GIS, the whole slew of mechanisms to manage these assets. But again, the key from our perspective is there has to be an internal data structure from the very start, and that's what's happening within program to BIM. The assets that Kimon is describing have the data structure built already inside these assets. So the users are simply entering the data as needed, at their different parts through the process.
Excellent. Thank you, Cyril. And thank you for joining us from your vacation in Canadian National Forest. That's the advantage of these technologies, is you can join us, but it also interrupts your vacation. Thank your wife for lending you to us.
Will do.
Okay, so we're back to Port X. This is the Port X location. And like John showed, we started using this as a parking lot for the different types of assets that are needed. Do we need a terminal building for 3 cranes, for 4 cranes, for all these different boxes here actually represent all the detailed command centers that I showed you. And we can do quick simulations here as well, directly in the map. So this is a GIS view, and you could drill into the individual requirements. Then we took it and we said, what happens if we take it to Tokyo? So we moved it to a landfill area in Tokyo that's about 2 miles away from the housing complex that I showed earlier that we worked with Searle. So these are all the location of the site that then you can start simulating, putting the actual building. So now we're actually landing the specific terminal building that would support a berth of this long, how many cargo ships can fit here, and how many cranes. It all becomes kind of just numbers at that point in graphics. And then the last thing, I'm going a little bit quick because I just want to get to the Google Earth view. All of this data that we showed you then can be used to tell the story. The story is we have the world. That's what fascinates me about port facilities and containers. It's a worldwide requirement, right? And each part of the world has different needs. So as we were working with John, we started trying to understand how containers and ships even work. What are these things called? It took a week just to understand the terminology. We have an STS crane, shore to ship crane. I learned it, I think. And there's containers in the yard. But that was not the most important thing for us, because as you saw in the simulation that John showed, they can run simulations of cranes and containers. But what we wanted to do was understand the logic behind it, so we can get to, okay, we have now Port X. In Port X, we have buildings that support those cranes, the facility, the assets. So these are the actual buildings that came from the BIM or M models that we talked about earlier, that have information in them, including early cost and area. And this is the specific space. This is the operations center building. This is each of these blocks represents the equivalent model in the other tool that I showed that is connected systems to systems, digital twins talking to each other as things change. And then we also had corporate housing that we had in Tokyo with Cyril. So we had the actual model here of the buildings there. So these are very detailed M models or BIM models, but here they're massing models that can be used for that storytelling purpose. And you can see the housing in context of the surrounding buildings even. So there is a new building, that's existing building. This is all VR and 3D and everything kind of merged together. So a lot of different systems talking to each other enable this. And the connectivity that's exciting for me is what John showed with the port requirements, to be able to tie it back to the why. Why are we building this? We're building this for a specific purpose that was driven from the business process model that drives the need for space, that drives the need for assets, that drives the need for buildings. And all this data is constantly shifting and changing, even for a single port facility, because ports are dynamic, but also for any port facility in the world. You can use this engine now to drive digital twins into anywhere, really. And we're showing ports and port facilities, but it really applies to everything.
So John, I saw you smiling.
Yeah, no, it's funny because we just take for granted, you know, when we throw all of these acronyms around, and then but it's actually been great for us to work with people, you know, where you don't, you know, you're learning each other's business. So it's been fascinating for me because I think from everything that Kimon is doing, when you know, we talk about the buildings, but being able to get our cranes and equipment in there, to be able to get the components down in digital twin form, you know, all part of this information model. I mean, it's just, for me, I'll say it's a real game changer in terms of the speed and the accuracy that we can develop and move forward. It's just fascinating, I think.
Yeah, we both learned a lot from each other these few short months.
And a lot is going on. So Kimon, will you explain how this connects to what you're doing with the National Institute of Building Sciences and other organizations?
Yeah, with the National Institute of Building Sciences, I'm presenting an AI session, AI in Building Sciences, a New Era of Intelligent Infrastructure, with Roger Grant and Jay Klein. And we're working with other government agencies through NIBS, but I'm also on the Digital Twin Subcommittee, BIM and Digital Twin, M and Digital Twin Subcommittee, I guess, if we go back to M. But there's a lot of interest in the intersection between buildings and assets and facilities and digital twins. There's another session with Tradeline that Cyril and I are going to be in Boston presenting, relating to spaces. And there's several other conferences after that, including the community colleges in November and NFMT. So it's an ongoing journey here to kind of explore. We're pushing the limits on certain things, but we're exploring and learning and present and sharing, I guess, is the other thing. We're sharing what's happening. That's
what a network does. So
Exactly.
Thank you. And John, you've got upcoming activities?
Yes, Mike, I have in October, I will be over your part of the world, actually, in Miami. So I'm a member, Trent and myself are a member of the Port Equipment Manufacturers Association. That's called PEMA, and their autumn meeting is in Miami. in October, so I should be going there. And one of the things that I want to talk about is this whole digital twin. I want to convey what we're doing here and what we've done and what we have. And I think the part that the equipment manufacturers could play in this in terms of information that we need. So
They have to in order to remain involved at this point.
yeah, absolutely.
And I'd like to also note that when you're in Miami, well, you're talking with Jacobs because you're colleagues with Jacobs and the Jacobs Ports, and Jacobs is a patron member, and IGO Systems is talking with the Asset Leadership Network to join, to continue to figure out how to get these stories that are visually clear. I see what you're talking about related to complex subjects, so that the owners can make decisions to move in this direction to meet the overwhelming need of humanity to increase efficiencies, to reduce energy. And people wonder how to do these things. And I applaud you for showing us. You're leading the way to a potentially better future for the world. So thank you. And this is only 1 minute over the official time. So we're going to just say thanks to our platinum member, ONUMA Inc. And ONUMA Inc. is a platinum member because they are working with other ALN members to make these types of presentations and show what's necessary in terms of collaboration to have this go forward. And John jumped right in and saw the vision of the ability to have the chutzpah to tell the global ports industry what to do going forward. So thank you, John, for that. And we have no shortage of boldness with the Asset Leadership Network. We're talking to leaders, and we feel very comfortable telling them what to do when we have members like you showing the way. And that's the official end.
Mike, we need to acknowledge Jay's input. I know we mentioned him throughout the presentation, but Jay
Thank you
gave us
for bringing that up again. And so we're officially over. If anybody has other meetings and stuff, but we've got people online that want to talk, and we can make you panelists. And at this point, we can just turn this into an open session. So Cyril, so thanks everybody for attending. Everybody stuck around to the end. Appreciate that. Cyril, do you want to say anything?
It's funny. I was just thinking as John was doing the presentations, we've got to get John's assets inside Collectus because it's I think that would be that's my next conversation with John. As soon as this meeting's over, I'll be giving him a call and we're going to have a conversation. So it's quite interesting. No, I think it's remarkable to see the opportunities at a ports level, and of course all of this technology is applicable with whether it's ports or buildings. It comes down to, as you've always said, Mike, it's managing the asset and how is that done in the most efficient and effective way. So kudos.
Well, thank you, Cyril. And yes, you're doing business with Kimon. I've got another person who's interested in talking to the two of you. I'm going to be going down to Miami and talking with John and Jay and seeing how we can promote other business opportunities for other ALN members. So that's a plug for people to join the ALN. And we've got Ryan Gear, who is an architect who's very familiar with these processes. He wanted to say some things. Ryan, longtime supporter of the Asset Leadership Network, welcome.
Oh, your audio
is not working, so you might need to change your microphone. And as we're waiting on that, it was really good to see and work with Jay. So Jay is kind of a Kimon of the ports industry. He understands the artificial intelligence. He understands the modeling. He's got a team all over the world. And he's also a really nice guy. Ryan, any luck with your sound?
We only
So,
present
we're
with really
waiting-
nice guys, right, Mike?
Yeah, basically, this is unofficial, but the Asset Leadership Network has a no asshole rule.
Oh, no.
And, we don't put up with anybody who's being jerky. And we, by being a leadership network, we are attracting top people, and top people tend to understand that we're working on a bigger problem than just one thing. And one of the things we're going to be working on next, the next ALN AiBrainStorm is going to be Tree Storm. And October 19th, we're going to be coming back to this type of venue where we'll be exploring trees as an asset. And we're going to be, we've got one of Cyril's clients is the university in Southern California, and they have a very robust model of all of their exteriors, including all their trees and bushes. And we're going to be showing how to tie those measurements to reportable outcomes, get other campuses, other large owners, cities, forest preserves, etc., to put their trees into a database and start measuring them. Then a colleague involved in the cryptocurrency world is going to tie a fictional cryptocurrency to the measurements. And as the measurements of reduced carbon and increased oxygen are registered, then the cryptocurrency will also tick up and down. So that is then going to be written and published in the American Journal of Economics and Sociology. And Marty Rowland, if you're available, and I'm going to promote you to panelist, you can start talking a little bit about that. This is the campus, right, Kimon?
USC, yeah. Is that what you said? I think you said
Oh,
USC. No?
A Southern California university. I forget the name of it. It begins with a P and it's on the coast. But anyway,
Yep.
yeah.
Oh, yeah.
Yeah, say Southern California University is fine. And Marty has joined. I don't know if he's able to speak yet.
No.
No. Is Ryan there? We can't hear you yet, Ryan.
Can you hear me?
There
Yes,
we
we
go.
can hear you now.
Hey, there we go. I've got a new microphone working. So yeah, thanks, Mike, for letting me join in and participate at this level. It's an honor actually to be amongst the knowledge base that's happening here. I mean, like you said, we've been talking about this for, I think you and I have been talking about this for 15 years with Kimon, coming on board with Kimon a long time ago. And it's super exciting to see everybody start to expect and understand and then be anxious to use this information. And so I'm looking to participate at a deeper level in this as we move forward here. I know you and I have a project we'll probably present at some time in the future that will use some of this technology. So thank you.
John, is there anything else to say on this picture?
Probably not. That's already
Okay.
been said, other than my dream to have everybody look at a more holistic approach to ports.
Well, that's the Asset Leadership Network dream, and that's why we're so aligned. Is human evolution occurred because we created divisions to focus on certain aspects of an organization, accounting, operations, maintenance, etc. That's how things got to where they're at. Now we have tools and processes that enable the melting down of those and a whole new leadership mindset needs to include information about everything in order to make real-time decisions that positively impact the mission outcomes.
Yeah.
Well, I think this is very good. You actually nailed it in the 1 hour. I was willing to go into this overtime because I thought we might have some, further things to discuss, but you guys really did a great job. Really appreciate all the time you put into prepping this. We'll be making highlights and making these available on the ALN website.
Where are we going next with this, Mike? You mentioned there's kind of a next step. Oh, we don't know the ports.
For ports, right, sorry. Yeah, kind of things have been happening in the background that we haven't even been able to, I didn't have time to show to Kimon. But in addition to reaching out to specific clients with John and Jay, we're going to plan a PortsSTORM 2 sometime in the future, where we're going to get input from real port owners and have them provide the problems that they're facing and the things that they want to address. And we'll use PortsSTORM 2 as a mechanism to show how they might think about proceeding forward. Now, this is based in the airport BIM storm that Kimon did for San Jose. And that was also a time when the virtual exploration involving people from all over the world to make suggestions resulted in the actual 10-gate expansion at the San Jose International Airport. So there's precedent for ports, just the airport was the previous one. Very similar. Information modeling, it's the same. So John, thank you for providing the formulas, the brain trust for the specific port industry information that needs to be modeled. Kimon, thank you for linking the building outcomes to the rules that the port faces. And both of you worked really hard to make this, really appreciate it. And thank you in advance for PortsSTORM 2 also.
Thanks for organizing it.
Yeah, no, thanks, Mike. It's been an absolute pleasure, Mike, working with you over the last year and a half, and been fantastic with Kimon and both Ukraine and this PortsSTORM. Really enjoyed it. So much more to now think about and discuss and take on from here. So really have appreciated that.
And thank you to all of the attendees, including all those who stuck around. So have a good rest of your day, everybody. And please send any comments or questions to me or through the ALN website.
Thank you.
Bye for now.
Bye.
Thanks, Mike. Bye.